More than 2,500 years ago, a boy named Icarus flew too close to the sun. His wax wings melted and he fell into the sea. Across the world, another story imagined something completely different. In Hindu mythology, the young Hanuman saw the rising sun, mistook it for a ripe fruit and leapt into the sky to grab it. Different cultures, different endings, one shared obsession. How close can we get to the sun? Thousands of years later, we finally have rockets instead of myths. So, how close have we actually come? The sun feels close because we see it every day. It isn't. On average, it's 150 million kilometers away. If you drove there at 100 kilometers per hour without stopping, the journey would take more than 170 years. Even light, the fastest thing in the universe, takes 8 minutes and 20 seconds. If the Earth and the Sun were placed just 100 meters apart, every planet in our solar system would fit inside that space. That's how enormous the scale really is. In 2024, NASA's Parker Solar Probe made humanity's closest approach to the Sun, just 6.1 million kilometers above its visible surface. On our 100-meter scale, Parker would be only about 4 meters from the Sun. And while doing that, it became the fastest human-made object ever built, almost 700,000 kilometers per hour. Fast enough to travel from New York to London in well under a minute. Here's where reality becomes stranger than fiction. The Sun's surface is about 5,500 degrees Celsius. But Parker flies through the corona, the Sun's outer atmosphere, which exceeds 1 million degrees Celsius. That sounds impossible. Imagine standing near a campfire and discovering the air above it is hotter than the flames. Scientists think magnetic fields twist, snap, and release enormous amounts of energy into the corona, but the exact mechanism is still an active mystery. So why does Parker survive? Because temperature alone doesn't determine how much heat an object absorbs. The corona is incredibly thin. There are very few particles to transfer heat. Instead, Parker's 11.5 centimeter carbon composite heat shield blocks the intense sunlight so effectively that while its front reaches around 1,400 degrees Celsius, the instruments behind it stay close to room temperature. Now for my favourite fact. Getting to the Sun is actually harder than leaving the solar system. Earth is already orbiting the Sun at roughly 107,000 kilometers per hour. A spacecraft can't simply point toward the Sun. First, it has to get rid of almost all of that sideways speed. That's why Parker spent years stealing tiny amounts of momentum from repeated flybys of Venus, slowly spiraling inward. Sometimes the shortest distance requires the longest journey. The closest any human has been to the Sun is essentially Earth's distance, about 150 million kilometers. Even with unlimited courage, today's technology isn't enough. A crewed spacecraft would need radiation shielding, cooling systems, life support, food, water, and backups for everything. Every kilogram makes the mission harder. The limit isn't bravery, it's engineering. Maybe that's why Icarus and Hanuman still matter. Neither story was really about the Sun. They were about humanity's instinct to reach beyond what seems possible. Today, myths have become mathematics. Wax wings have become carbon heat shields. Dreams have become spacecraft. Right now, the closest human-made object has reached about 6.1 million kilometers from the Sun. The closest human remains about 150 million kilometers away. But history has a pattern. Every generation reaches a little farther than the one before. So perhaps the question isn't, how close can we get to the Sun? It's who will be the first to rewrite the answer.